In this video, we're going to be dividing complex numbers. In number 1, they want us to multiply a plus bi times a minus bi. So this is equal to a times a is a squared. A times negative bi is minus a bi. Bi times a is plus a bi. And then we have bi times negative bi is going to be negative b squared times I squared. And our negative ABI and our positive ABI cancel, and I squared is equal to negative 1. So what we're left with is a squared plus b squared. And it wants to know if the result is a complex number or a real number. And we don't have any i's in a squared plus b squared, so this is a real number. And now, if you want to eliminate the complex number in the denominator of the expression 3 plus 2i divided by 5 minus 7i, what would you multiply by? And we would multiply by the conjugate of the denominator, which is 5 plus 7i divided by 5 plus 7i. And then it says, how is this similar to rationalizing the denominator of the expression 3 plus 2 square root of 2 divided by 5 minus 7 square root of 2? And we would multiply by 5 plus 7 square root of 2 divided by 5 plus 7 square root of 2. And 5 plus 7 square root of 2 is the conjugate to 5 minus 7 square root of 2. In 2, they want us to divide, i.e. rationalize the denominator, right in the form of a plus bi. In a, we have I minus 6 divided by 3 minus 2i, and they want us to state the conjugate, and the conjugate is going to be 3 plus 2i. Remember, same terms, change the sign for the conjugate. And now they want us to rationalize the denominator. And we have I minus 6 divided by 3 minus 2i times 3 plus 2i divided by 3 plus 2i. And this is equal to I times 3 is 3i. I times 2i is plus 2i squared. We have negative 6 times 3 is negative 18. And negative 6 times 2i is negative 12i divided by, and in the denominator we have a perfect square, so we have 9 minus 4i squared, and this is equal to 3i, and I squared is equal to negative 1, so we have negative 1 times 2 is minus 2, minus 18 minus 12i divided by, we have 9 minus, and I squared is equal to negative 1, so we have 4 times negative 1, which is going to make this plus 4. And when we combine our like terms in the numerator, we have negative 2 minus 18 is negative 20. And then we have 3i minus 12i is minus 9i divided by 13. And we could write this as negative 20 divided by 13 minus 9i divided by 13. In b, we have negative 4 minus the square root of negative 5 divided by 3i. And the first thing we want to do is state the conjugate. And that's going to be negative 3i. And now we want to rationalize the denominator. So we have negative 4 minus, and we can rewrite the square root of negative 5 as I times the square root of 5 divided by 3i times negative 3i divided by negative 3i. In the numerator, we have 12i plus 3i squared times the square root of 5 divided by, we have 3i times negative 3i is negative 9i squared. And now I squared is equal to negative 1, so we're going to have 12i minus 3 square root of 5 divided by negative 9 times negative 1 is 9, and this is equal to negative 3 square root of 5 divided by 9 plus 12i divided by 9. And now we can simplify one last time. Negative 3 divided by 9 simplifies to negative 1 over 3. So we have negative square root of 5 divided by 3 plus 12 divided by 9 simplifies to 4 over 3. And we have our I. And that's our video on dividing complex numbers.